All right, today's exercise on 7F, which we can do by hand, but I want to teach you how to use your CAS. When you use your CAS, and that's your home screen, do not use your scratch pad. Okay, so that calculate and that graph, don't. The scratch pad was designed so that you do a quick calculation. So for example, you don't know what the square root of, 578 is, and you just want to do a quick calculation, that's okay. If you want to do a quick graph, that is okay. Thanks, team. What's the problem? When you start doing larger calculations, which is here, that's the one we actually use down there. If you don't use that one and you do the things I'm going to teach you today, eventually it breaks. Meaning that if I give you a year 12 application question, if you keep following it, at some point the calculator cannot calculate because it wasn't built to do it. It was built for quick calculations. And if you wanted to do something that's repetitive or does deeper calculations, it breaks in Scratchpad, but it doesn't break in the other section. So that's happened in my year 12s because you're doing year 10, you're doing year 11, and you get by with Scratchpad. But then in a SAC, which is when it counts, it breaks. And I don't know why it breaks. And we found out it's because Scratchpad is a quick calculation. That's why it's called Scratchpad. And the actual place that you should be doing your calculations actually should be this one. Okay, so the one that has that times, divide, plus symbol, that is actually the calculator page. That one, when you start doing the things I teach you, if you did longer calculations and deeper processing, you can handle it. You can't handle it on the Scratchpad. For your everyday stuff, we'll be fine. Yeah. So as a habit, please do not click on calculate or graph, but actually go to the add calculator page. So here's your document. Notice it's called 1.1. So that's page 1 of problem 1. It means you can have multiple problems. I'm going to teach you a couple of things on how to use basic skills of CAS. But let's start off. Let's look at first question. You need to first start modeling. And I'm going to teach you how to do modeling and then how to solve, how to sketch, how to do those kind of problems on your CAS, okay? Let's start off. Should I get one? Here we go. Example 1. It says a rectangle has 20 meters as their perimeter. So let's draw length, width. They tell you that x meters is the length of one side. So I'm going to call that x meters here. Find a formula for the area. So what we need to first find out is the starting point. It says perimeter is 20 meters. How do I find the perimeter of a rectangle? Can I please have Jaden? Good. Twice the length plus twice the width. In our case, I called length x. So it becomes 2x plus 2w, which I still don't know what w is. So let's call that the width, w. And the perimeter is equal to 20 meters. It's equal to 20. So I got myself an expression or an equation. This is equation number 1. Okay. My second equation, they're asking us to find the area of the rectangle. What is the area formula for a rectangle? Can I please have Rowan? Good. So width times length. Now we do have length. We called length x. The problem is we don't have width. I don't know what width equals to. So it's a problem if you have an equation with two unknowns. Okay, so if you have two parameters or variables, then it becomes a problem. So what we need to do is to use this equation 1 so that we have it all in terms of one variable, meaning we just want it in terms of x. So that was hidden. So they say, hence find the maximum area. So you need to first have the area formula all in terms of one variable. Right now I've got two variables. I've got w times x. Can't solve that. So that first equation, when you say perimeter of 20, was meant to be a hint. The hint is you need to rearrange this equation to make w the subject. And when they say the subject, it just means make w single. Okay, so let's rearrange this equation. Now we can do it by hand. I'm going to show you how to do it in CAS as well. Let's do it by hand first. Here we go. If I want to get just W by itself, I need to remove this 2x. How do I get rid of 2x on the right-hand side? What do? Subtract. So here I'm going to minus 2x on both sides, and I get 20 minus 2x is equal to 2w. See what I'm doing there? So all I said was subtract 2x on the right, subtract 2x on the left. 2x take away 2x cancels out. That's why I'm left with 2w is equal to 20 minus 2x. We're almost there now. We almost made w the subject. Again, my goal is to find w. I don't want double of w. I don't want times 2. I just want w. So how do you get rid of that times 2? Divide. What if you do to one side? You do to the other. Make sure that you divide every term by 2 as well. Here we go. 2 divided by 2 cancels out. 2 divided by 2 is also 1 here as well. And 20 divided by 2 is 10. So that brings us to w is equal to 10 minus x. So that means your area formula is now, instead of w, we now know w is equivalent to 10 minus x. So we're substituting that w as 10 minus x times x. This is a quadratic equation. So you notice that it is something times something. Something times something equals that. Now usually it's y equals, but this time they've actually got it in terms of a context. It's area, and x happens to be the length. So you've got a problem to deal with. Now we're going to try to model this. How would you have done this on a CAS? And what are we going to do with the CAS to solve the problem? Because we can do this by hand, we can also do it on a CAS. Yeah? Here we go. On your CAS, how do you rearrange this? They say at year 12 level, sometimes these equations are pretty nasty. Doing it by hand is possible. It's just that you're probably prone to mistakes and it's time consuming, right? And if the question doesn't need you to do it, for example, this one didn't ask you to write perimeter in terms of a certain value, then you don't have to do it. So here, go to your CAS. This is what you do. Menu. Algebra. So I'll do it again. Menu. Click on the menu button. You can press the number 3 if you can't be bothered pressing the cursor. So this cursor up and down brings it up and down. But you can actually just press the number 3 and it'll select that row or column. And you go to solve, which is number 1. So I tell my students press menu 3-1 is what I tell them to do. So press menu 3-1. You get solve. Okay, what are we solving for? Well, we had this equation to begin with. We had 20, which is the perimeter, equals, Jaden said it was twice the length, which we called 2x. Now notice there's a dot between mine. In your calculator, get into the habit of actually typing the times button. Okay, so in the latest update, they actually break if you don't put a times between the letter A and a B, for example. So if it was AB and you told it to solve for A, it doesn't know the difference between AB and the letter A until you put a times between them. Okay, so in this case, get in the habit of actually using the times. I'll show you an example later so you can see what happens if you don't put that time symbol. So it should be 2 times x plus 2 times w. Right, so it's not a QWERTY pad. You actually have to look for the letters. It's in alphabetical order. So it's 20 equals to 2 times x plus 2 times w. That's the equation we had. What's the solve? Solve is what you want to make as a subject. Usually we solve for x. Usually we solve for the x-intercept, the y-intercept. We've got an equation, but in this case, I want to make w the subject. So notice I have a comma there. Comma is just next to the O. Make sure to put a comma and then type the w. So you're telling the calculator, here's my equation. I want you to solve, meaning rearrange algebraically, to make w the subject. Okay, meaning make it by itself.
In the brackets?
All in the brackets. That's correct. All within the brackets. And if you press enter, it should give you exactly what we got. Yes? I'm going to copy that. I'm going to screenshot this and bring it in so that you've got something to see. So we can go back. Here we go. So this will give you that line that you just did as a calculation. I'll just make it a bit smaller and chuck it over here. There we go. So we've solved it. Great. So you did this instead of doing it by hand. You could have done that. But you still needed to model it. Regardless, the calculator can't model it. You have to model it. So you all still have to come up with this first expression to know what you need to do. Next step, area. Now, one of the practices, especially in year 11 methods, you're going to use these formulas quite often. So one of the things that we start teaching you to do is instead of typing this equation over and over, 10 minus x times x, yeah? So this is your area formula, right? What you don't want to be doing, here's an example. Don't write this down. If I asked you if the length, so x represents the length, if x equals to 3 meters, what would the area be? Now, normally students, what they do on the calculator is they go, oh yeah, well it just means make x 3, and they will write this in. So they go 10 take away 3 times 3, right? I know you can do that in your head. That's 7 times 3 is 21, right? But when the equations get bigger and you have to type in multiple times, you don't want to be typing that over and over. So there has to be a quicker way to do it. I'm just going to delete this line so you don't get confused. There we go. The quicker way to do it, and it's the recommended way because later on when you do applications, they have sub-questions and you use it over and over. I want you to go to get practicing using this action. It's called menu. Go to actions. So menu 1. Okay, menu, action, so number 1, and then 1 again. So I normally say to my students, menu 1, 1. This define essentially tells you that you can use a substitute letter to represent that equation. Okay, so instead of writing a equals 10 minus x times x every time, you can give it a letter. So here I'm going to use the letter A. So I'm going to press A. You got to use brackets though, open brackets. Brackets next to the 0. Type in the letter x because our equation has the letter x in there. If it was t, then we use t, right? Close brackets. So this is saying area has the letter x in my equation is equal to. Now what was our area equal to? It was 10 minus x times x. Type that in. So we go 10 minus x times x. Once you're done, press enter. It should say done. Now, what's the benefit? I'll show you. See the example I just did before? I said, what if x was 3 and you had to sub it in, right? All you have to do now, instead of typing the equation again, you can just type A. Notice it's bolded. It's bolded because you've defined it. If I now replace the x with a 3, because I'm saying let's make x equal to 3, gives me 21 as well. See, so that means I can ask you multiple things. I could say, what if x was 10? You don't have to type it again. You can just do a bracket 10, and it'll tell you, which makes sense. 10 minus 10 is 0. 0 times 10 is 0, right? If I said, what if x was 9? So if x was 9, you just do a bracket 9, and it substitute 9 for you, rather than actually doing x equals 9, a equals 10 minus 9 times 9. That takes too long, right? Especially when the equations get longer and longer and more fractions and surds, you want to define first. Okay, so for every application question with my year 11s, I teach them to define the function first and then use that. And if you define it once, it means you can sketch it too. So you can actually sketch it without retyping the equation again. You only type it once, you can actually sketch the graph from there. Yeah, so here we go. What are some benefits? Here are some benefits. Let's go to a graph. Let's teach you how to do a graph, okay? Actually, I'll leave this a equals 3 so you know. Yep. Oh, for those who want to know how to delete, in the middle of your pad, there's a the cursor. move the cursor to this line, okay? And then if you click on control, escape, or is it control? Yeah, control menu. Control menu. So put your cursor where you want to, right click, essentially. So the control button and click menu, there's a little blue icon there, means right click. So if you put your mouse here and you do control menu, it comes up with a subcategory.
Just click up. And you just click history, right?
Oh, you can do that too. That's quicker too. Yes. But there's also a clear all. So you can clear the entire thing if you wanted to as well. Ah, good question. These are just to answer this question, listening. Shh. Eyes and ears towards the board. There's a couple of things. Because you use the letter A, sometimes you might want to use the letter A again. And let's say you want to use it for something else. You can actually redefine it again and it just overrides it. Or, sorry, Jen. Yeah. Or you can go menu, actions, and see how it says clear A to Z. So if you've done a lot of letters like A, H, T, and P, and then you forget what letters you've used or defined, by going to menu 1-4, it will clear all the things that you had defined beforehand. Okay, and then it just starts on a clean slate. So that's one of the ways to clear it. All right, team. I'm going to show you how to graph this, and we can do a bit of calculations just using these simple 3 functions. I'm teaching you today solve, factorize, and expand. Just 3 things, yeah? Here we go. Can you please click on control and then doc? Because the blue icon says plus a page. So you're adding on a second page now, and we want to try adding on a graph. So number 2. So control doc 2. Yes, Violet. All right. We're on this page. Good. Are we good? It's an inferior version, but yes. So, one of the nice things is you can actually sketch this graph now by typing A bracket X because you defined it before. Yeah, so you don't have to type it again. So once you type it once, you type A bracket X, or did you? You can actually do, I think, control Z. It means undo. You can actually undo it too. Z. All right, press enter and you should get a graph. Now the graph is not set well. We can't see the graph well. Here's a few tricks that you can do. If the graph ever looks empty or there's something that's too big for you to see, because notice the domain or the x values are only from -10 to 10, and the range or the y values are only from -6.67 to 6.67. So it's pretty small. Yeah? So to readjust it, there are 3 ways that I teach my year 12s. Go to menu. Yeah, don't do the zoom. That's what most students do. It doesn't really give you a good scale. So I'm going to teach you a better way. 3 things that you only do. Menu windows. Here's the zoom in, zoom out, which a lot of students do. It's not good when the functions get really big because then everything looks really tiny. You can't see it. The 3 things I only ever teach my students, and I don't really teach anything else but these 3, is window settings, zoom box, and zoom fit. Those are the only 3 you need, and you should be able to sketch every graph and be able to visualize. Now, what's each one? Zoom window settings is a manual way, so you can adjust it manually if you can read the equation and you can figure out what the maximum minimum is. Zoom box is the best. My year 12s only just discovered it this year, and they're like, oh my God, no one taught us this. I'll show you how to use it. And zoom fit is your AI automatic fit. It's not always the best, but it is the go-to. I go to that first and then see what it gives me. So if you go to zoom fit, let's see if it automatically fits well for us. Here we go. Go to menu 4 and then press the letter A, zoom fit. So it gave me a better picture, but not really perfect to the way I want. Now, there's a couple of things you can do. You can actually make it bit closer, because what we want is this section. Why do we only want this section? Can someone explain to me? Logically, because this is the area formula. Why do I only want to look at the top half? Why? Because the intercepts, that is true. Also, there's something else. When it comes to area, what can't area be? Girls? Area can't be negative, so this bottom half doesn't make sense. How can you have a negative area rectangle? Doesn't make sense. So this area we don't need. Also, length, x can't be negative as well, so we don't need this left side as well. So we only need this top half. So how do you get to that bit? Don't do zoom in. Zoom in's a terrible way of doing it. Use my zoom box. Here we go. Menu. 4. Try zoom box. How does zoom box work? So it works. Move your cursor. You pick 2 corners. Pick the corner that you want. So I want roughly somewhere here. Click once. Go to my next corner. So I'm like maybe somewhere over here. Click twice. Doesn't that look much better? See that? That's my graph. Yes? Yeah, because I've got exact values. Don't worry about that.
I have exact values.
All right, so let's say the graph is not fully there yet. You can't see the x-intercept on the side. Here's another little quick adjustment. Move your cursor to the x-axis. And if you hold onto your cursor button, press onto it until the hand goes like a clasp. It grasps onto the axes. So hold on to, so notice my hand is open, but if I press on it, whoops. There we go. Can you see how it's holding onto it? Now I can actually change the axes manually, and you can do exactly what I'm doing right now. So hold onto the mouse until the hand clenches. It closes in, and then you can just move left and right to adjust it. Okay, so sometimes that's a nice quick fix. And then you tap anywhere else on the screen and it stops. You can also move the page as well. So if you put your cursor somewhere on the page and you hold it for like 2-3 seconds, you should be able to move it like this. See how I'm moving left and right? You can actually do that as well, okay, with your cursor. So it just gives you a bit of a view of what's happening. All right, so on everyone's screen, I want to be able to see a perfect graph. I don't want an estimate graph. You don't have any graphs? What happened? There's 2 ways, and I want to show you both. The algebra way and also the CAS way. Now the CAS has 2 ways. To go back to the previous page, you can either use your cursor and click on 1.1, or you can click Control and arrow left, and it just goes back to the previous page that you had. Okay? Now, remember to solve for the x-intercept. On the graph, can you see x-intercepts occur when y equals 0? But this is not your y-axis anymore. What is this representing again?
The y-axis.
Now, what variable? What variable have we defined it as now? It's the area. Yes? A, area axis, A is equal to 10 minus x times x. So this is your x variable, and this is now your area. So, if you want to find x-intercepts, it's when A equals 0. Right? It's when A equals the area. When does the area equal to 0? So, that means you can do again what you've learnt. Menu, algebra 3, 1 solve. I want to solve for the function a of x. When does a equal to 0? Comma, x. Because what that's saying is, what you're doing there is, you're doing this. You're saying, if this is your equation, a equals 10 minus x times x. You're saying, why isn't it purple? Here we go. When a equals 0, that's when you're able to find the x-intercepts, right? So you get 0 is equal to 10 minus x times x. This is a of x. So I'm saying a of x equals 0, solve for x. Now using null factor, I can already tell you it's a 10 and 0. But I'm trying to teach you how to use a CAS. You're ready to find this. You don't have to type it again. The calculator knows this is a of x. So a of x is equal to 0, and what are we trying to find? X-intercept. So here, I type in, I said, solve 10 minus x times x, that's what a of x means, equals 0, so I'm saying let this equal to 0, and then I want you to find my x variable, which is the x-intercept. So x-intercepts occur when this equals 0, that's what I'm doing here. So you press enter, I expect 0 and 10, which is, we were to do it by hand, you get 0 and 10. Yeah, so this is, how do you solve x-intercepts after you define? You see that? So once you define it once, you can do a lot of things here. You can find the turning point from this too, right? Copy that. I'm going to screenshot this later so you guys can have a record of it. Go back to your page. Let's say you didn't like this and it didn't really make sense to you. Here's another intuitive way. Go back to your graph page. So control, right. So let's go back to the graph page. You want to find the x-intercepts? You can do it from here too. Menu. Analyze. That's where you find everything that you need. Maximum, intersections, and all that. Go to analyze. And the x-intercept is the number 1. It says 0. What they're trying to say is when the graph equals to 0. So if you select on number 1, okay, so analyze graph, go to 0. See this line? You essentially select the boundaries where you think the x-intercept is. So if I want the left intercept, I go click once on the left of it, click right on the right of where I think the x-intercept is, and it works it out for me. So it tells me at 0, 0. If I want to find the next one, which I can tell it's over here, then this is what I do. Menu, 6, 1. I do the same thing again. To the left of where the x-intercept is, click once. To the right of where the x-intercept is, click once, and it'll calculate it for me. So I got 0 and 10 just the same way. You can also find the maximum through the same thing. So if you want to know what the maximum height is, menu, 6, maximum, number 3. So 0 is x-intercepts. Maximum means find the maximum turning point. So here, if I go to the left, anywhere, left of where I think the turning point is, click once. Go to the right of where I think the maximum is, click once. What does this mean? This is your x-coordinate. Remember, x represents the length. So when length of the rectangle is 5, then my area has a maximum value of 25. So this rectangle that we're describing can only have a maximum of 25 square meters. Okay, based on the graph, based on the equation 10 minus x times x. The values in between, no matter what you choose in between, it either increases over time, and at some point if you increase x, it starts to decrease the area. That's what the parabola is describing. So I can tell you in this particular rectangle, this equation that we made up, the maximum area you can get is 25. Okay, and that's the kind of questions that they were asking. So what was the question that was asking? It was asking, what's the max area? The maximum area this shape can have, 25. Okay, but where do most students get it wrong? They don't know how to read this. So they can type it, they can sketch it, they find this point, but they don't know what that means. So they'll say 5. And I'm like, what does that mean? Why is it 5? Well, sometimes they just pick this number and they say 10. I'm like, why is it 10? What are we talking about here? This is saying when the length is 10, area is 0. When the length is 0, you get 0. It makes sense. You have no length, no box. And here, this represents x when the length is 5 meters, and the maximum area is 25. That's it. So it's about reading this, knowing this means area by length. But each problem changes. Depending on what application problem you're doing, you've got to read the graph, how it represents it. Okay? All right. What else can you learn? Oh, here's one last one that I thought could be good for you guys. Complete the square. For those who struggle and want to check their answers, you can go menu, algebra, and if you scroll all the way down to number 5, it says complete the square. So menu 3, 5. And it will complete the square for you. So menu 3, 5. Type in the function a bracket x, comma x. How beautiful is that? See, all I did was define it once, and I never have to type it again. I just work with what I have. And that allows you to already read the turning point. Move to the right by 5, It's a frown type of shape. It's up by 25. Beautiful. It's a lot for you to watch this video again.
This is too complicated to...
All right, team. I'm going to stop there. Next lesson, I'll continue on with a bit more CAS, but I just wanted to give you a bit of practice there. So you got define, solve, complete the square in sketching. Watch my video again to practice, but that should get you started in an application if you're up to that. All right, I'm going to stop the video.